Hi and welcome to part 4 in this mechanical rigging tutorial in 3dsmax. This time we are going to do the basic setup of this track, and it looks like this. So I have one master control controlling all the tracks and the wheels. So yeah, let's get started. Okay, so first let us isolate the tracks layer and set it as active layer. We're going to delete one of the sides. Just want to rig one and copy it. I'm going to hide the gears for now. And let's see here. So this time we're lucky, the links have correct pivots. What we're going to do, we're going to make a spline around the track. And we are going to have a helper on each link, that's path constraint. And they are controlled by one master helper, and each helper has an offset according to the distance of the links. So first we need to make a spline, and let's see where we want to be the first link. This one is closest to 0, so let's go with that one. And let's see the direction. When the track travels in the positive X direction, the track is going to rotate clockwise. So this is going to be the direction. I'm going to name this track 1. First I'm going to select them in order. I'm using the paint selection tool. Then I'm going to Tools, Rename Objects, Base Name, Track Link, underscore, numbered, starting from 1. So when making a spline, we could use snaps with pivot active and go like this, but that is boring, so we're going to do it with a script. Scripting, new script. So make it a bit bigger. First we're going to declare a spline object. We call it TP for track path equals spline shape. And we need to say that we are going to draw a spline in this spline shape object. Add new spline in TP. Then we're going to need to make a loop where we make a vertex on each of the pivots in the selection, in the correct order of course. So for O in selection, do add not. That's a function for adding a vert, and we are doing it in the TP object on the first spline. We said add new spline here, so this is going to be the first. Then we are saying we want a corner vertex and a curve segment, because we may want to smooth it later. Then O pos is going to be the position of the vert. And then we are going to close the spline. Then update shape TP. And let's just set the name as well. Track path R and select it. Then we need to select these in order, evaluate. So this looks right. Yeah. Then we are making a helper. So this is going to be the master control. So let's go here, position, assign, path constraint, add path. Then just copy it as a copy, not an instance. Track link 001, let's call it that. Make it smaller and green. On the percent, on this one, we're going to add an expression. So position, percent, assign, float expression. Let's make a variable called control, then assigned the master control percent. Let's just see that it moves with it. Yes. So since I know there are 34 links, an offset would be plus one over 34 times 1. Then the next link would be times 2 times 3 and so on. Let's just leave that for 0 for now. I also want the links to have a look at constraint that looks at the next link. So I'm just going to add a look at constraint here. Why doesn't I see it there? So it's going to look in the x-axis. I want the up node to be this track path. So when I rotate it, it will follow along. And the source and up node axis are going to be y to prevent flipping when we go around. I'm not going to add a target yet because I want to create all the links first, so I have something to add as a target. What you could do, you could clone and go here in the path constraint and edit the expression. But again, this is pretty slow, so we could do this with script as well. Make a new script. So we don't have sort of a 34 selection here, so we're going to just say for I, which is going to be the index of the loop, to 33. do h for helper equals instance of our selected here. So we're going to instance it. Then we're going to edit the expression on it. So h position controller. So it's position, and the control on the position is the path constraint. Then we are accessing the percent and the float expression controller on here, and we're going to use the method set expression. Then we need to write that expression, which was control plus 1/34 times this is going to need to be a string plus I as string, which means for every loop we're going to, instead of the 0 we already have, we're going to do 1. Next loop is going to be 2, 3, all the way up to 33. So let's evaluate. Somehow they got some weird colors. Let's just test here. Yes. Then we need to set the targets here. Again, you could go through every one, but let's do a script again. Let's make an array here first. The array equals selection as array for e equals 1 to 33. Do why I didn't go on to 34 is because we're going to set I plus 1 for the target, and 34 doesn't have n plus 1 since there are only 34. So we're going to link the add the final one just manually. So this means the helper in the array that has this index, so it's going to be the first, then the second, and so on. Rotation, controller, and append target. Then we're going to set the next one as the target, the array I plus 1. And we're going to need to set the weight of that target. So let's go for 100. and the other parameters of the lookup constraint we set up before. So let's go evaluate. And I don't like these lines that go everywhere. So I'm just going to do this here. Controller, look at vector length equals 0. Then you see the last one here doesn't have a target, and because there is sort of a chain here with lookup constraints, you would get a dependency loop if you can't choose it, but we have this one master, so we just add that one instead. Then we just need to link up the geometry. Let's just hide splines. Let's just hide this one as well. So again, you can go and link every link to every helper, but again, that's boring. So let's first select everything in the order from the Scene Explorer is the easiest way. Scripting, new script. So we're going to split this selection in one array for the meshes and one for the helpers. So let's just do my helpers equals for O in selection where class of O equals point collect O. And let's just copy this. My meshes. Then we just go at not. So select or add the objects in this selection that's not of the class point. So let's loop. We're going to use the indices because for every loop we're going to need one mesh and one helper. For I equals 1 to my helpers.count, do my meshes at I index dot parent is my helpers index Y. And then evaluate. Yes. Then we I'm going to set up these wheels. So let's see here, there are 10 links and there are 34 links on the belt, which means the ratio is going to be 3.4. Let's add an expression here. Add a control variable. We're going to take in the percent here. Isolate it. Percent. So one whole turn of the belt with 34 links. And one turn of this one is 10 links. So 34 divided by 10 is 3.4. And that is one turn. And we are going to multiply by 360 degrees and convert it from degrees to radian. So deg to rad like that. Just copy it over to the other side. Track wheel. And front right. And you see here it's kind of looks a bit wonky, but if we smooth it out, I'm just going to do it in a modifier so I can change it. Yeah, so now it looks a lot smoother. Yeah, so I think that's it for this episode. This is sort of just the basic setup, and we're going to do more with it in the next parts. Thank you for watching.